Okay, for our final lesson in compass radial, in trigonometry, we're going to deal with compass radial surveys, and this allows us. Compass radial surveys allow particularly surveyors to go out and find out the lengths of boundaries, the area of blocks, and these sorts of things that are used. Now, I'll go through the process here. Actually, I'll go through the process first. So, you basically make a scale of the block. We go to some point in the middle of a block of land or something like that, and you call that O, or the origin. And basically all that's happening, the process for it's a bit different, all spelled out there in detail, but what essentially happens is we get the bearing of a straight line from where we are to a corner of the block, so a point at which the boundary changes. And then we can measure that distance. And then we get the bearing around to the very next corner of the block, and then we find that distance. And so what we're going to end up with here is a situation where we have a whole bunch of triangles, and we kind of know, we know everything there is to know about the angles in the centre here, because that's bearings. We've been using bearings for all of that. So we know we can work out every angle in every one of those triangles that's displayed there. And then, so as long as we know that, we can use the cosine rule to find the length of a boundary. Because obviously we don't know the length of the boundary, we know these interior lines. And we can use the area of the triangle formula to find out the area of each triangle, which is probably the greater use, because we can then find out the total area of the block if we do that 4 times. So to give you an idea of how this works in practice, this is a bit of from Google Maps, the area where I live. And you can see, while there is a property here with a curvy boundary, most properties have rather square boundaries. And so if we take any particular block and put a sort of origin point in the middle, we can measure in each direction from each corner of the block back to that origin point. And what that ends up doing is creating a whole series of triangles. And given now with trigonometry we can find the area of triangles where we don't know where we don't know the height of the triangles, we can use trigonometry to find the area of triangles. We can use the cosine rule to find the lengths of boundaries. It's a tool used very heavily by surveyors, councils, town planners, those sorts of people. Okay, so just going through off this particular example we've got here, for the radial survey above, calculate the distance AB. So the distance AB is in the triangle OAB. So in triangle OAB, angle AOB, because we're going to need to know that angle in here, we're going to need to know this angle. Well, it's going to be 106 degrees minus 70 degrees, because the bearing at point A is 70 degrees, the bearing at point B is 106 degrees. So if I take away the 2, the difference will give me that size of that angle. So that's going to be 36 degrees. Now that I know that, to find the distance I'll use the cosine rule. Sorry, I just have to cough. So here we're going to be using the cosine rule to find a side. So we're going to want that in that form of c squared equals a squared plus b squared minus 2ab cos c, where c is the angle that we know. So c squared stays as c squared because we don't know what that length is, but we do know that a squared in this case is 850, well 850 squared. And the distance B is 670, so 670 squared minus 2 times by 850 times by 670 times by cos, and the angle we just worked out was 36 degrees. And I plug that all into my calculator, and I'm going to get, so 850 squared plus 670 squared minus 2 times 850 times 670 times cos of 36 degrees. So that's going to get me that big large number, 249929. And so C is going to equal the square root of that number. So if I take the square root of answer, I'll end up with 499.9. We'll go with that, 499.9 metres. So we might say something along the lines of, therefore, distance AB is 499.9 metres. Okay, the next one there we've been asked for is the distance DA. So DA is in the triangle DAO. So now the north line is always going to be drawn here, but unless we actually measured a distance to a corner of our block that was due north of our origin, the north line's not part of that triangle. So the angle I'm after in this particular case is going to be this angle here. Okay, so to find this angle here, I know that it's this part over here is 70 degrees, and this part in here is going to be 360 degrees minus 315 degrees, the difference between those two angles. So in that case, I might just solve that up here. 360 take away 315, so that's just going to be 45 degrees. So that being the case, sorry, I'm just going to have to pause again. I've got battery issues. So in DAO, angle DAO is going to equal 45 degrees plus 70 degrees. So you can see here the 45 back to north plus the 70 on from north around to point A. So that's going to be 115 degrees. So in this particular case, I'm going to need to use the cosine rule again. So I'm going to have to use that c squared equals a squared plus b squared minus 2ab cos c. Remembering in this case that the angle, so I'll have 560 metres is going to be one of my sides, 850 metres is going to be one of my other sides, and I'm actually after dA along the top there. So I'm going to leave that one for you guys to do because it's identical to the first one. I'll leave that as an example in Edpuzzle for you guys to have a go at. So finally, the area AOB. So the area AOB is in this triangle here. I already know the angle because we worked that out before. Angle AOB is 36 degrees. And to find the area, I'll just use the area of a triangle rule. So the area of a triangle is going to be, did I just move everything? No, I did not. Good. Half AB sine C. So in this case, that's going to be a half. Now our A and our B is going to be the same as before. It's going to be those two sides. So it's going to be 850 and 670. Times the sine of that angle, which we calculated before was 36 degrees. So I put that all into my calculator. .36 degrees. And we've got an area then of 167,371.9 metres squared. All right, so it is expected to get a fair bit bigger. We might, in these particular circumstances, change that to hectares. You might be asked to change it to hectares. Obviously, a hectare is 10,000 square metres. So we've got 16.7 hectares. But in this particular example, it hasn't actually asked for us to do that. But yeah, it's quite likely in this sort of situation we might be required to change that to hectares or square kilometres or something like that. Okay, and then finally we've got this example here, example 2, which is a radial survey of the wetlands near the golf club in Casino. So we want to find the size of angle FOA A. So we want to know this angle in here. So if this is 60 degrees and that's 328 degrees, then we're going to have a situation where it's going to be angle FOA, first of all, equals 360 degrees minus the 328 degrees on this side. So that'll give us this. That'll give us this first part here, and then the second part, this part here, is just going to be if we add a further 60 degrees. So that's this part here. So we can just key that into our calculator really. So 360 minus 328, that gives us our distance before north, and then we're going to add to that our distance, angle after north. So it's 92 degrees. I'll take that back to the same colour pen, 92 degrees. Okay, and then the area of triangle EOD. So for that we're looking at this little triangle in here. It's a poor colour, I'll try blue maybe. There we go, blue's a little bit better. So we're looking at that triangle in there. So first things first is we need to know the angle. So in triangle EOD, angle EOD equals 265 degrees minus 250 degrees. So that's going to be 15 degrees. So the area of that triangle is going to be, the area is half AB sine C. So that's a half times by our length A is 331. Our length B is 299. And the angle we just worked out was 15 degrees. So we plug all that into our calculator. Times by 331, times by 299, times by sine of 15 degrees. Close our brackets, and we end up with 12,807.5 metres squared. Okay, and the next thing we're asked, the final thing we're asked, is the length of the Queensland Road frontage. So that's going to be, the Queensland Road frontage is that distance FA. So given that we've already worked out what the angle is in that particular triangle, we'd be using the cos rule. So we'd be using c squared equals a squared plus b squared minus 2ab cos c. And in this particular case, we've got 282 is one side, and our other side is, I can't see because of the pen I put over that, so I'll just get rid of that bit of pen, 313. Oop. Minus 2 times 282 times 313 times by cos, and how big did we say that angle was in the first place? We said it was 92 degrees. So we plug all that into our calculator. So 282 squared plus 313 squared minus 2 times 282 times 313 times cos of 92 degrees. We're going to end up with 183,653.8 something something something, but then of course c is going to be equal to the square root of that. So we take the square root of that and we get 428.5 metres. And that's the end of that question. These are very common in HSC questions, so please have a good go at them. Thanks.